All right. So since I am both the moderator and the presenter, I guess I'll just introduce myself. Always, always different. But for those of you that haven't met me, my name is Craig O'Neill. I am the Business Development Director for FLIR's optical gas imaging line of products, with global responsibility of the strategy of our products and our solutions to try to make sure that they meet your needs in the emissions mitigation, LDAR, or whatever market that you have there. I don't know, as far as I've been with FLIR for 21 years. And I have been directly involved in optical gas imaging since the launch of the world's first commercially available optical gas imager called the gas blind IR. I'm just curious, has anybody ever used a gas blind IR? We do have a couple of old soldiers in here, some legacy OGI guys. So appreciate y'all sitting in. So today, most of what I'm going to talk about are the advancements that we've made in optical gas imaging. I don't know how many have been able to see our stop by the booth, but we really, after many years of having a similar portfolio and a platform of our cool flagship optical gas imaging camera, we have made some I would say some leaps and bounds, or some pretty large strides in what I have sitting up here. Sitting up here in front of this. I'm not turning this on because y'all don't want to hear the hum. I love it. It's sound of money for me. But I put it next to my bed and let it put me to sleep at night. But yeah, so we got the camera up here, but I want to talk a little bit about that. I don't know. I would imagine at this conference, everybody knows what this slide means, but just in reference, in case there is some newer people to the technology. What optical gas imaging is, in essence, it is a way to see invisible leaks, right? We're doing gas detection through a unique engineering process of an infrared camera in which we leverage the absorption spectra of hydrocarbon gases or whatever gas you have there. The key advantages, of course, is emissions mitigation, but safety, right? This is something FLIR's been in for over 50 years. That's why we make cameras. To make sure people are safe, whether they're in an oil and gas facility or utility facility. We get into a variety of products. This is an idea of unsafe, operations, as you can see. Enhancing productivity and ROI. We want you guys to make money. The more of that gas you can keep in the pipe, the more that you can actually sell. And so we feel as though our technology is pretty unique in that case, and allow you to have a higher ROI, keeping your equipment running faster, better, longer. And then reducing business risk. What do we mean by that? That last line is what's changed the most, in my opinion, in the last 4 or 5 years. Right? When I talked about OGI 5 years ago, I never walked in here and said, "Hey, Fidelity, you can pull your company off of their platform trading." Right? So that piece of it, of reducing business risk, ties a little bit back into the emissions mitigation when you start looking at that environmental safety and corporate governance aspect of the business and what we're able to do here. So again, I have some videos. I guess one of these these others didn't loop around, but when we get in there and before we do this, I will take that trip down memory lane. I already had a couple of hands go up. What are some of the things that we have done? What are some of these technological advancements over the years of optical gas imaging? In 2005, we launched the very first gas blind IR. It was the first commercially available optical gas imaging camera to the market, right? So unique product to the market. It was very funny. I think I have time because I think it's presentation. We would go to shows in 2005 and we would show people that gas leaks, right? We're visually showing them something that today is just like, oh, it's an OGI camera and it sees gas. But back then, people were in between that first year. They were just looking at it and they were almost like, I don't know what to think. Right? It was pretty amazing how far it's come. Year two, what was interesting is they came in and go, all right, tell me about it. But year one is like, I can't see it visually, but I can see it with your little camera. So pretty interesting where we went. In 2009, which is pretty unique, is where we began the platform of our GF series. This is our flagship camera since that time in different models. And so if you think about that, the portfolio or this platform is what we're announcing today, a realistically revolutionary change with respect to the advancements that we're making in optical gas imaging. And what was unique, you're going to see a little bit of this theme here today, is that we listened to you. Right? We looked at the first camera we had. We needed to get something to market for a number of reasons. There was customers that wanted it. EPA was involved in the early discussions, but there was a little bit of customer feedback, right? User feedback to ensure more efficient use, had onboard storage. And these were things that at that time, there was no, now you walk through that exhibitor hall, there's a little bit more of those OGI camera companies than there were back then. Back then, there wasn't anybody else. And so we were competing against ourselves, but we wanted to just make a better product for you, for our customers. So we really did some unique stuff there. In 2017 is where we launched the GFX 320. That since then has been the flagship camera for us, and I believe in the industry. It was the first third-party certified ATEX camera. So, you know, we used a third-party house. We didn't want to coincide and say, hey, we say it's a class 1 div 2. No, we want them to say it. They'll even give us a nice little pretty certificate that we can put on our website. So the very first time that happened. And then in 2020, we launched our first uncooled optical gas imaging camera. And again, this is lower cost, different market, doesn't meet regulatory compliance or anything like that. But realistically, and you know, people say, well, you know, why don't you do that? It's not a need, but what we saw at that time and before was now you go into all of these, you've got these alternative measurement technologies, right? You've got these alternative ways to find leaks, do emission management. And this is kind of a foundation of that. I talked a little bit about that in my fixed, uncooled, agile presentation yesterday. So, you know, really kind of moving along. There have been some other iterative changes, right? We took this camera, put it into a fixed mount housing in 2014. We still have this product today. We don't do a whole lot of it because of the high cost. This is a camera that somebody asked us to do it, so we did it. But the reality is it's a camera that's not really made the way the technology is. These cameras are made to use handheld, all this, not really made to do 24/7. But we had that. We have some use cases for it, and some partners that really have done some really interesting things to help ensure the longevity of use of this. And then 2016 was pretty revolutionary. And what we did in 2016 is we partnered with Providence Photonics, who actually they're giving a presentation right now at the same time in another room. But we partnered with Providence Photonics through a minority share investment with them. And we began our road down quantification, right? Allowing optical gas imaging users to actually quantify emissions with their optical gas imaging camera, utilizing a third-party tablet. So what do we do today? We actually took a lot of this stuff and we wanted to literally take a top-down approach and look at what we can do. A little choppy on the video there, but so we launched this. We have a brand new series. It does look a bit the same. It's not the GF series. The GF, a lot of people thought that stood for gas find IR, right? Was what most people assumed because that's what we replaced, right? We took the gas finder, but that stood for gas and furnace. That's one reason that it's the G series now, because we have a furnace camera. Some of you may be familiar, probably not at this show. We do have a furnace camera that we are right now in an engineering phase with that camera to be able to see through flames, look inside of the furnaces, and be able to effectively inspect your tubes for coking and scaling and look at the boilers and other applications. But as we looked at this, we wanted to figure out what do we want to do, what do we need to do in this, and we wanted to make sure we have an advanced replacement of our existing camera portfolio. We took a lot of user feedback. We listened to what a lot of our customers said, and what was interesting was that a lot of that feedback was, please don't change the camera, right? Please keep it similar. Keep the buttons where I know where my fingers go, where I know where they are. That was probably the most surprise that we've had. The biggest surprise we've had in talking to a lot of users is they didn't want drastic changes with respect to the portfolio in the camera itself. But what we want to do is make sure everything else. Think of it this way, right? A 2010 Chevy Tahoe, the engine is very similar, right? The transmission, it's an engine, you've got to transmit, those things look, but think about the inside, right? What is the inside where the radio is and the navigation now from 2010 to 2023? Think of it like that with respect to this camera, what we're able to do here. But we wanted to look at this and we wanted to do what FLIR does. We wanted to not just say, all right, let's make a sleeker camera that's a little bit better. We wanted to add groundbreaking features. We wanted to add features inside the camera that can help you today. And we think there may be things in here as we listen to the industry talk about where things go, may help you in the future, may help you understand what you need later on down the line. And then we did understand, we listened to you. We understood that our digital ecosystem, the wireless communication technology inside the camera wasn't where it needed to be within the FLIR portfolio. We felt as though we had a great camera, but we knew that that was probably a little bit of a pitfall in the GFX, in the GS series. So we took all of that. And as I mentioned, you'll notice this phrase, together we've raised the bar again. We started right before COVID beginning to have interviews with customers. What do you want? What do you this? Reality is, COVID was right about the time we were going to begin development of this product. I don't know if many of you know, FLIR was in a unique position during COVID because we could measure surface temperatures or temperatures of things from afar. We could do everything from afar, so we could actually measure your tear duct to tell you whether or not you are increasing your skin temperature and potential at risk of having a fever. And so everything got put on hold for about a year with respect to FLIR's R&D and everything. And a lot of the stuff that just started not only got put on hold, but restarted. And then after that, we came back and we began talking this, and we wanted to listen to say, not only this is what we think, do you like it? We said, we did that with a couple of things, but what do you not like? What are your pain points in a FLIR camera? And these are just some of the statements that we had. You know, it's fragile. The display is exposed. The viewfinder takes external hits and it's really kind of wonky. The battery door, I don't like the way it operates. Quantification, I got to use another device to quantify. That's cumbersome, right? Wireless communication didn't have. And again, as we began talking, please don't change the buttons. Please don't change the way it is, because I like the advantage that FLIR has on the ergonomics of their camera. So as we looked at that, we wanted to look at the design. This is part of the initiatives of our product management team. They said, all right, here's what we're going to try to do. We're going to maximize efficiency for our customer base. We're going to take this and we're going to put the side mount display, which is very similar. We're not going to change that, but we're going to make it easier to use and more efficient. We're going to enhance the viewfinder because people complained about that. And we're going to enhance, if you will, the feel of the camera. In reality, it's built a little bit more rugged. And we want a simple interaction. The buttons are a little bit different. Instead of having a button that's already set to do something, we just made it programmable and give you an option of doing what you think you would like to happen within that button on the camera. So very simple interaction, very similar to the previous models. But we wanted the ergonomics to change. We re-engineered the LCD, and one of the little things, right, it is, you know, it's kind of nice at a trade show, is I can actually turn the screen around and let you see what you're looking at on the camera. But you can also seat that screen back on the camera itself. If you wanted to actually type in notes, because it's now full touchscreen design, you can actually start typing in notes on the camera, being able to easily do that. And again, touchscreen display. And then the rotating hand grip, it is more rugged with respect to how tight it is, and to ensure that the ergonomics still change the same. And again, for us, that's all, you know, that's a good thing about having a engineering operation suite. They're very proud of their ergonomics. They don't want somebody holding a camera like this all day long. And that's something that we appreciate, at least I do, whenever I have to get out there and do extended demos, right? You can hold the camera down by your belly or your waist, make it very easy to look at the LCD screen. If you do need to use the eyepiece, there's none of this. You just simply tilt everything on that. You haven't seen the camera. We were asked, please don't fix what's not broken. Don't make a new detector. Don't make a new technology that we don't know the sensitivity. We don't know how well it's going to work for what we're able to do. We want to make sure that the EPA requirements and the operating envelope that we used yesterday, we can use tomorrow. And so we did that. That's why I said the engine of the camera is the same, right? The detector of the camera. We didn't change that. We didn't change the optics. That was purposefully done to ensure consistency within our portfolio. We were also to make sure it has ATEX certification. So we kept the same certification as ATEX, but what we did do is we now have a 640 by 480 4x resolution ATEX certified camera from FLIR. It'll operate exactly the same way. Because we make both the high and the low ones, I'll tell you the stinky little truth that most other manufacturers of cameras aren't going to tell you. High resolution is not better. with respect to gas imaging, right? If you think of it this way, I have a certain size, it's a detector, right? I have a certain size piece of paper that I can put pixels on. And if I put the same amount of pixels, or if I put more pixels on that same size detector, which is the size of what's in this camera, each pixel is smaller. When each pixel is smaller, it absorbs less energy, right? The well of that pixel. So a high resolution camera, while it may produce a little bit prettier image, and I'm not saying this, sorry, Isaac Newton is, while it may produce a bit of a prettier image, physics says that the gas detection sensitivity or the NETD or the sensitivity of that camera itself is going to have to go down, have to sacrifice resolution for something, and that is sensitivity of an IR image. If you want a prettier picture, you want more pixels and more resolution, but you're willing to sacrifice a little bit of sensitivity, we have that option. But if you want the most sensitive to optical gas imaging camera in the world, we still have the 320 camera, which we feel as though is going to be still going to be our flagship camera because it is the most sensitive to gas detection. That's the main purpose of the camera. And then HSM, right? We have a patent on HSM. It's probably the most broken patent out there that we've ever owned, but we have the patent in HSM in the FLIR ergonomics that we wanted to keep available within the FLIR portfolio. But we wanted to make gray even better, right? We wanted to ensure this. Now, I don't recommend doing this with your camera, but we did it for you, right? Taking this $100,000 device and just slamming it down on a concrete floor, right? This was in our laboratory environment where we actually have an impact testing. And so we've done this for you. Don't do it. But we understand that you're not in a lab environment yourself. You're not doing this in a medical lab. You're doing this outside. You're walking up. It's banging off of handrails on stairs, going up to a catwalk. And we understand that you have that challenge. We wanted user consistency. I'm just curious, and this is maybe not the right conference. Has anybody used a different FLIR camera before? Not an optical gas imager, just an infrared camera from FLIR. Just curious. Okay. A handful. Today, if you buy our $1,000 C5 camera, which you have on the table there, it's not OGI. But if you buy a temperature measurement camera, you buy this optical gas imaging camera, the user interface of it will look the same. The functionality of this camera didn't completely change. For example, we still have a mode wheel, it's better. We still have an HSM button, it's just better. The same button didn't move. We've got an extra program, we've got the laser, we've got a temperature measurement scale button on the side, so a pre-access button. None of the ergonomics of the camera, but when you get into the camera, the ergonomics of the GUI, graphical user interface, is the same. And if you have a suite of people that may do this, this is really important to some other industries, like our utility industry, where they use the cameras for sulfur hexafluoride detection, in which they may have a bunch of people that use a $2,000 camera, and then all of a sudden, hey, Bob, can you go use the OGI camera from FLIR? I've never used it before. So it's a huge advantage for us across our platform. And another feedback that we got was we want more, we want expanded use, we want versatility. In the ATEX camera, we want to be able to change a lens, and I want to have the ability to stand in the same place and see twice as good at four times as good. So we do have a variety of optics, and this includes our ATEX versions. You can have interchangeable optics on your ATEX optical gas imaging camera from FLIR and the new G series. We did add advanced features. One of those is something we've had in our other cameras called one-touch level and span. Now, this is one of the things that I don't know. A year from now, people may say, Craig, you're crazy, and this really doesn't help us at all. A year from now, y'all may come back and go, that was the one feature that we loved. Because when we launched this in our first camera in 2017, we didn't think anything about it, but all of the users in the infrared world loved it. And what that is not to get into theory, but the way an OGI camera or an infrared camera works, it looks at it and says, what's the hottest thing I see? What's the coldest thing I see? And I'm going to always change that. So if I come over here and look at the wall, there's not a big change. As I look at you, all of you, I get up to 98 degrees, go back to the wall. So what we can do is when we put it in manual level and span, you simply touch the screen, you'll see a little white circle, and it is only adjusting the entire level and span in accordance to what is inside that little white circle. So you may be able to now be in manual or auto level and span, simply touch the screen, and you may get better definition potentially even the high sensitivity mode to be able to see gas leaks. I don't know. We'll figure that out down the line, but it's a really, really cool feature on our infrared well. It's added in there. If you're using the HSM, some people didn't like, you got to go into another menu and you click it. Anytime you go into HSM, you simply touch here and it's just a slider bar. Go all the way down to 1, up to 7, leave it at 3, 3.5, middle of the road, whatever it is. So again, user interface, a lot easier, we feel, and a lot quicker in the field for you to be able to do your inspection. Maximize your time in the field. This one is one of those ones, as I said, we may be meeting future needs in the market. And this one could be regulatory. If you read Appendix K right now, it doesn't require a video, and neither does quite a way. But what Appendix K does require is it does require documentation and proof of the component leaking with a photograph, or you can take a video. With OGI, it's always been a little bit of a challenge, right, to be able to show in an image a moving leak. But now, because it's touchscreen, you can tell the camera every time I say the image, not a video, but an image, I would like to add a sketch. So now it's just touchscreen. Use your finger, draw a circle around that, whatever it wants. That could meet Appendix K's requirement of having a picture that defines where that component is leaking or what component is leaking. And then lastly, we have a very quick one of the quick access buttons options is to turn delta T indicator. Now, delta T, as we all know, the term delta T has been one of those Appendix K challenges over the last couple of years, particular, or OGI challenges in particular with Appendix K. I don't know, we don't really know where this is going to go, and there is a little bit of vagueness on what delta T is. There's some people that say delta T is just, I'm just going to put a really cheap temperature measurement, a thermometer, like something that looks out, and it's just going to say, this is the temperature of everything in front of me. But I don't think that that's what delta T is going to be defined in the long run. I think delta T, by definition, as it relates to gas imaging, it's going to be on a pixel level. By definition, it can change. I can't just take an average temperature here and not assure that I have the appropriate delta T of this component. If I'm looking at the sky, my average temperature, if I just have a little temperature thermometer in there that just says, I'm going to take one temperature, and my ratio is going to be 20 foot by 20 foot, well, that's not going to be the same as what the true delta T is on this component to ensure that I can inspect it with a 2-degree or a 5-degree delta T change that I need. So we now have just an option in the camera to set your delta T as you want. And now I can turn a little P button on the side, just turn it on and off. I could be looking and say, all right, in my process, when I get into an area that I'm going to go, I just need to turn it off, on, turn it off, and it's going to go red or not. It's going to show me where I have red. And ironically, I actually had it on all 3 of these. But where I have red, I don't have the 2 degrees. But that's only a small percentage of the pixel. I can't just take a broad number and say that applies to everything within my field of view. The probably most groundbreaking technology on this is where we began to listen. We don't like that third party or that secondary device when we do quantification. And so now with the mode wheel, I'll turn it on here in a second, but with the mode wheel, you'll see just have the same mode wheel look as we used to have in the past, but we have some new things. We have multi-rec or multi-recording, which I'll get to next, and we also have quantification. So now, without any secondary device, you can quantify in the camera. This is what it looked like. I would simply take this and roll over to this. Right now, I'm in manual level and span, so we just simply did a one-touch level and span. I can go into my parameters here, and all these parameters are what are on the QL320 or the Q mode now. Choose my gas type, methane, ethane, propylene, benzene. What gas do I have? Right here, we're just in a lab. And then what color is my plume? When you're done with that, you go down here and you actually will tell us, right now this is in ppm meters, tell it to start. You need a tripod and get 4 or 5 seconds to set that tripod up. Right now you need it steady, extremely steady. Then it's going to calculate what's happening here. You can see the numbers change. Then it will begin measuring and colorizing the plume. Color probably won't have pink in it, but we're still in the finalized. And then here you go. You're going to have your ppm meters numbers. This is not ppm. This is ppm meters. You're going to have your documentation or your number. And then when you're done, simply tap summary, and it's going to spit out a single image what we were just looking at, right? With the number on there, your ppm reading number there, and you're going to have all of the data. I don't have this. You're going to have all of the data that you put in. What was the delta T? What was my temperature ambient? And at the end result, because it's a touchscreen, if you wanted, you can add notes. And just say, hey, I would like to add more notes, and here pops up a keyboard. Start typing in the notes of what you'd want to keep on there. Really super simple, really easy to use. Another feature to some people just kind of as we were looking at this is called multi-wrap. And what this is if anybody have used a FLIR camera or any other camera, sometimes I don't remember which button it is that I can switch from my infrared to my visual, right? Or where my HSM button is or any of that stuff. So if I wanted to go take, let's just say 3 seconds of infrared, like a standard infrared, 3 seconds of high sensitivity mode, and 3 seconds of a digital camera. In today's world, you've got to change those modes. What we did it called multi-rec, where we go in and we set the camera up with how many seconds of each mode or imaging mode you want. You have to hold it steady for that aggregate number of seconds. We don't have a frame buffer in the camera to be able to switch between the different video modes. So if it's 3 + 3 + 3, it's time. Well, back then you had to do 3, 1, 2, 3. You know, now you just hold it steady for 10 seconds, and it's going to record everything. So these aren't French fries. Here's your leak right here. This is just a small, I think this is just a cigarette lighter built in the middle of that. So you can see it right there. Can't see what's happening. Now you'll notice in the infrared mode, if you look closely, you can begin to see the leak right here. See it very well. It's a pretty small leak. See somebody toggling it on off, and there you go in the high sensitivity mode. You'll notice they didn't have to do anything. Nobody's touching things. You didn't see the camera bump around and move when they're looking for the button to switch from one scene mode to the next. What if you have to store 10 seconds? How can you ensure that you store 10 exact seconds? If you wanted, you could say 10 HSM. Every time I record, it's going to automatically be 10 exact seconds. So again, is this going to help me regulatory drive in the future? I don't know. But we want to add unique things like this to the camera to try to help make your life easier, make your life more efficient, to let you get in that field, let you get out of that field, get your kids, get to the baseball game, whatever it is you need to do after that. And then communication, right? We've got a full, up-to-date, today's world of communications. We've added a Bluetooth so that you can do voice over text or voice over video within the camera. And what you're going to have Wi-Fi, which is standard in most everything, but now it's in the FLIR camera now, so we can communicate. I need to get with a lot of the third-party LDAR reporting companies to say, hey, we're ready to go now. They've always said, just call me when you're ready. So now we're ready. Right? We've got it. We've got the camera. We're ready to go. You can do that. You can also Wi-Fi peer-to-peer. You can download images. I don't have to take the SD card out. I can download images through Wi-Fi if I want, or I can actually Wi-Fi a live streamed image to an iPad. We have a little device called FLIR Tools Mobile. I just hold the iPad. Guess what? I got to do my Appendix K QA/QC. I've got to follow this guy around once a quarter for 2 hours. It's a lot easier looking at an iPad versus looking over his shoulder. So you can do little things like that. GPS, same. We still have the GPS. We've updated or upgraded the antenna that we put in there. And we still have the FLIR GPS logging feature. So we'll do a breadcrumbs map, a breadcrumbs CSV file within the camera. And then we've added FLIR Ignite. This is something that we've had out in our other cameras that have had Wi-Fi for a while. What this is FLIR's cloud-based service. So these other cameras, it's very simple. You just simply turn the camera on, it's got Wi-Fi. You say, all right, hook up through a Wi-Fi. And it's just like your phone. When you get into a place and the Wi-Fi is on and it's previously connected, it's going to reconnect into that Wi-Fi. So you've got this camera, it's storing on the files, and there you go. It's going to send these files to the cloud. And now that's going to happen with the FLIR G series. As soon as you're connected to the Wi-Fi connection, whether that's tethering from your phone, maybe you have a hotspot in your truck, but once you connect once and that Wi-Fi is on, the Wi-Fi is on the camera, it's going to automatically send those into our cloud called FLIR Ignite if you want. You can turn it off if you don't like having third-party clouds. That's up to you. But we also have a feature called FLIR Ignite Sync. And what that does is on your computer. Now, if your computer is on and it is on Wi-Fi, and you've activated, which it's automatically asks you when you turn your computer on, do you want to turn FLIR Ignite Sync on? In that case, anytime it's on, it's told to be on, and you're on Wi-Fi, it's gonna pull stuff down. So think about that. You could be out in the field, take videos. When I'm done, I'm driving from point A to point B. I've got a hotspot in my truck, and my camera's over here. It's just running it, you know, and I've got batteries charging, whatever it is, but I'm just running the camera. There you go. Then you keep going from A to B. It's going into the cloud. And then you call your boss, hey, can you check that, your computer, because he has access to your FLIR Ignite, account. You need to check that video real quick and make sure we don't need to send somebody out tomorrow or right now. So really, really unique in what we can offer there. While it doesn't apply as much to this industry, we do have, and there's some people in here that may have some needs, but we do have a variety of cameras for other industries and other applications and markets. So we are not just replacing our hydrocarbon cameras, which most 99% of the people in here are used to the 20 models. We are actually replacing the full portfolio of our cool camera solutions. So if you do have carbon dioxide, which is, there's some people in here that use our GF343 camera to do carbon dioxide optical gas imaging, we will have a G343 camera with all the new features. Please note that quantification is only in our hydrocarbon model. Right? We have a carbon monoxide model for the steel industry. We actually have a hydrofluorocarbon model mostly for the chemical industry. And then the predominant market for our 06 model, our G306, is going to be the electrical utility industry looking for sulfur hexafluoride, or also known as SF6 gas. So one thing that we feel as though we have is a really unique, complete solution. I've even talked about some of the software that we already have in our portfolio. That's not really a new launch. We have a software called Route Creator. I know another camera manufacturer. This is another patent by FLIR, so we'll have to see where this happens. But we actually have a patent to be able to add a route into an infrared camera. And so we have had multi-years experience. Usually this is around a substation in a manufacturing process or in a manufacturing floor. But we have Route Creator. Now we have the most unique and feature-rich optical gas imaging camera in the market. We have a cloud-based out of the thing with 1 gigabyte of free storage. Out of it, you don't need to do anything. You don't have to pay a dime. 1 gigabyte is cloud storage. You can pull up and down as you see fit. And then we have FLIR Thermal Studio, be able to analyze stuff if you want, or this could be replaced very quickly and easily with a variety of a suite of these LDAR camera or LDAR software reporting programs that are out there that we can actually now talk to through Wi-Fi. They just have to look at our API and write some code for themselves. I do want to at least mention a few other FLIR advancements not directly related to optical gas imaging per se, but some people may or may not know acoustic imaging seems to be popular in there. And this is not a regulatory compliant technology or device from FLIR, right? This is just the ability to try to look for leaks according to the sound that they make, right? And that's what acoustic imaging is doing. So it is, we don't envision that. We recently purchased the largest acoustic imaging company in the world called Acoustics. They are completely under the FLIR portfolio now. This is our thing, extremely efficient to be able to take that first line. It is a really, really easy to use and valuable tool for quick imaging. It sees leaks faster and it's easier to interpret sometimes, but it is going to miss leaks. And that's the problem that I see with acoustic imaging, and why I don't ever see it being regulatory compliant, is because of the potential of inability of false negatives, not the false positive you have. But it does, and our primary market historically for this has been two. One, partial discharge in the electric utility industry, but also for compressed air leaks. Ever heard of needing to retrofit something in the oil and gas industry with compressed air? What's different is a lot of the compressed air leaks that we see today are in the manufacturing process. If I have a leak and this thing goes dry, I mean, air gases a mile away, I'm going to have them come back and fill it up, and I'm going to figure out what my leak is. This industry, you may have to have a compressed air tank, and nobody's getting out there to service that compressed air tank for a while. So it would be nice to be able to know whether or not you have minor leaks of compressed air that are going to cause you to have some considerable problems in your controllers at some point in time. So it's a unique product that I see a place in this market as well. I just don't ever see it being regulatory compliant. I talked yesterday on our complete autonomous OGI solution, so I won't cover that. But we also have a Zone 2 rated infrared camera. It's around like $2,000 to $3,000. I don't know the numbers off them. It's a lot less than the JAG cameras, put it that way. But it's just a Zone 2 housing that you put a camera into. And if you have a scenario where you need a quick and down and dirty IR camera to go look at mechanical or electrical inspections, there you go. We've got one super easy. It's about this big. It's a little bigger than an iPhone. Because of the case, it's a little bit bigger than that. Imagine an iPhone and a really big art box case. That's about the size of the camera and the enclosure that we put it into there. As we look at acoustic imaging, why would you look at FLIR? We did some third-party testing. We had a company saying, you know what, there's all these acoustic imagers out there. We want to test yours with everybody else. We just launched, I think today, a new camera called a LD Plus. And so I won't say what manufacturers there are other than the ones that we have. This is the one launched today. This was our detectability for distance measure, the detectability range and the distance we have out there. We only evaluated all of the competitors at the initial 1 meter range, but our new camera was better than any competitor out there in a third-party testing apparatus. Super simple field operations. What is unique about that? So if you're looking at like a methane, if you wanted to kind of say what do you have, Craig and FLIR for methane detection, we've got the good, the better, and the best technology out there in our opinion in the market. So you really have a really unique way of being able to have multiple solutions from one group within FLIR. Want to learn more? This camera, as I mentioned, launched 2 days ago. So brand new to the market. We're making them now. We'll begin shipping our ATEX versions in early May. And so there's more information, FLIR.com/G-series. This is my email if you ever wanted to reach out. We've got various brochures in our booth and online. And are there any questions? Yes.
I saw in your quantification that you had parts per million.
Yep.
You also run that as like grams per second or grams per hour or whatever units.
Right. I mean, the video we have was just ppm meters. Yes, we will have complete flow, whether it's mass or volume and all of that. You would have to run those independently. So if you wanted to run, you can't just say how many parts per million meters, and there's no algorithm that says, hey, I can actually put this in my calculator and change that number to this number. But in flow, whether it's mass or volume, you can actually change that as you see fit. But yes, we will have one of those drop up menus. It's weird because we used to always call them drop down menus in our GF series, right? Now they're pop up menus at the bottom. One of them I didn't show, we didn't go over in the video. You would have gone up and you have your choice, concentration or flow. Yeah. Any other questions? Yes.
You touched on the multi-record capability as being programmable. Is there a simultaneous visible light and infrared recording option? Or
so you do have the capability of, and I have to double check whether it's with the video. I know with the infrared image, you have the capability in the camera to say every time I store an IR image, if you want to store a JPEG, a visual JPEG at the same time. In the video, I don't have that, and we're not going to store two videos because to do that, just to kind of give you what happens in the camera, you have to have a frame buffer in the camera that separates the video streams, which would mean you'd also have to have a way to have two recording devices in the camera that separate those and push those both onto an SD card. It can be pretty complex and quite bigger and stuff like that. So, but we do have a automatically save a visual camera. I know it's in the imagery. I don't know if it adds it to the video, but I can check it out. Yes.
So when you have the screen facing out
Yep.
and it's displaying,
Yeah.
Can you still see through the eyepiece as well? When that
I'll check. That's a good question. I haven't had that one
we've had, passing it back and forth, like
out here.
if somebody could if somebody could
Oh, I see
know,
what you're saying.
again, you could see at the same time. I was just
Yeah, I don't know. Usually, that's a good question. I don't know the answer to that, and I don't think it's something out of the realm. I didn't think about, yeah, if you're doing your inspection you want somebody to see what you're doing, that kind of thing?
Yeah.
Yeah, so that's a good thing. Right now, it's usually one or the other. But I'll check that here at the booth here in a minute, and if it's not, I'll talk to my engineering team to see if it's an option. Any other questions, comments, complaints? There's some other people from FLIR, you can give those. That's it. Well, hey, I know that y'all got a lot of different, different things to do here and a bunch of other presentations. So I appreciate you giving me and FLIR your time, Teledyne FLIR. I'm still not used to it, but appreciate you giving us your time. We're here. We still have our booth up and ready to go. We got the camera out. If you wanted to get some stick time this afternoon, be here early tomorrow morning as well. But yeah, we're proud of what we've got here and look forward to getting this thing in your hands. Thank you.